I wanted to do one more example of the Master Theorem and its application to algorithms. And I wanted to talk about merge sort, which is a method for sorting a list of numbers that hopefully many of you have seen, but I want to express this in terms of a recurrence. So let me remind you what it means to merge two sorted lists. So let's say I have the list 2, 3, 7, 12, 14, 22. And then I have another list, 1, 5, 6, 9, 17. And I'd like to merge these two lists to get one sorted list that includes all the elements. So this is sorted list 1 and sorted list 2. Let's merge them together. So we basically start with two pointers. One pointer at the beginning of this list and one pointer at the beginning of this list. And we see which one's bigger. Is it what I'm pointing to here or pointing to here? And we see that which one's smaller? We see that the 1 is smaller than the 2. So we write down 1 and we advance the pen one way, that way. Then we say which one's smaller, the 2 or the 5? We say, oh, it's 2. So we write down a 2 and we move, again, the pen one step to the right. Then we say which one's smaller, 3 or 5? Again, it's 3. So I'll write down a 3. I'll move my pen over. Then I have to compare 5 and 7. So I do 5. I'll move my pen over. 6 and 7. 6. Move the pen over. 7 and 9. 7. Move the pen over. 9 and 12. 9. Move the pen over to 17. 12 and 17. 12. 14 and 17. 14. 22 and 17. 17. And then 22. So if I have two lists of numbers and the length of this entire list of numbers is n, then it takes n operations to merge. Okay, so if the length of both of these lists together is n, then it's going to take me roughly n operations to merge. And by an operation, I mean looking at what number is above one of the pens and advancing a pen. So I advance each pen. The total number of times I advance the pens is n, because this one will get to the end of its list, and this pen would get to the end of this list. So this is just sort of a long-winded way of saying if you have a list, two lists of numbers, they have n numbers in total, it's going to take about n operations to merge the two lists into one sorted list. Okay, so how does merge sort work? Well, it says the following. Take a list of length n, unsorted, then recursively sort the first half, sort the second half, and once we have a first half that's sorted and a second half that's sorted, we can merge them. And that's the algorithm. So let me sort of draw how this works. So we have a list of n numbers, call it A1, A2, through n. It's unsorted. So we'll recursively sort A1 through A of n over 2. We'll sort an over 2 plus 1 through an. And we'll merge them. We'll merge the outputs of these recursive calls to obtain, we'll call it B1 through Bn. This is the sorted list. So how do we write a recurrence for the number of operations that we need in order to sort a list of length n. So let's say T of n is the number of operations needed to sort a list of length n. So it's the number of operations needed to sort a list of length n. Well, from the above description of the algorithm, we have to do T of n over 2 work to sort the left half, plus T of n over 2 work to sort the right half. And then we have to merge these two sorted lists. But as we just said, if you have two sorted lists and they comprise n total elements, it takes time n to merge them. So we're left with the recurrence T of n equals 2 times T of n over 2 plus n. Well, now we're in great shape because we have a recurrence. We want to get a big O estimate on T of n, so we can use the Master Theorem. What does the Master Theorem say in this particular situation? What is A, B, C, and D? A is 2. B is also 2. C here is 1, because it's 1 times n raised to the 1 power. So D is 1. Let me try and look at the Master Theorem. So we have A is 2, B is 2, C is 1, D is 1. So let's look at the Master Theorem again. Remember, A is 2, B is 2, C is 1, D is 1. Okay, so in this case, it looks like we have A equals B to the D, because we have A is 2 equal to 2 raised to the 1. So A equals B to the D, so our solution is n to the D log n. So again, our solution is n to the D log n, because A is equal to 2 to the 1. So this implies that our solution is order n to the D log n. This implies that T of n is order n log n. So there you have it. We looked at the algorithm that you've seen before, merge sort. We wrote a recurrence for its time complexity, and we used the Master Theorem to get a big O estimate on the number of operations it takes to sort a list of length n.